welcome to the first Rust Computer Vision Meetup. So it's exciting. It's exciting for me, and I think for hopefully for all of us here. So I just put together a few opening remarks, and the first thing I wanted to say was give a very brief and very incomplete history of Rust, and maybe trying to capture some of the reason why we're here, maybe. So 2015, there was this announcement, Rust 1.0, and the idea was, okay, it's this language which is going to be fast, reliable, and productive, pick 3. So this is kind of really exciting for people doing, computationally intensive image analysis, video analysis, and I think that encompasses pretty much all of us here. Then Jordan Worley, who's here today and will be talking, he created this Rust Computer Vision organization on GitHub and a Discord channel. So probably if you're here, you may be aware of these things. So Jordan's really been doing a huge amount of work on some projects of his, but also I think this Discord channel has really shown me there's a lot of people sort of out there with interest in Rust computer vision, and I sort of have the idea that for every person that actually interacts on the internet, there's probably 10 more that are just lurking. So I guess that actually there's quite some interest in Rust computer vision, and so I'm excited about this meetup tonight, and maybe even more so what maybe this community could do in the future. So just maybe a couple more points. You're all familiar with these things, but maybe this is part of what I think is bringing us together. What are the good things about the Rust language? And maybe the most important one for me is that there are these sophisticated compile time abstractions that you can write, and they compile down to 0 runtime cost. So this is for me just incredibly exciting as a way to make sure that complicated software is kind of correct and that no problems sort of spring up later that you're going to have to spend countless hours trying to deal with. Something else I think is very appealing, and we're also going to see some of tonight, is that the same source code runs very efficiently on all kinds of different hardware, from embedded devices, including tiny microcontrollers, to web browser, to powerful machines, workstations or servers or whatever. So it's a resource-aware design. When you program in Rust, you have to be very aware of resources, which also means very aware of data. And then finally, in terms of concurrency, it's just a wonderful language to deal with a lot of the problems that come up with concurrency. And, there's some downsides, and I think many of these are getting better. But one of the desires is, I think, sort of the counterpart to the first one about the good abstractions, that there's sort of this, programmer's desire to make perfect APIs. And I think, when you're programming in Rust, you have this incredible sort of, ability to see, if I just do it this way, it'll be a little bit better. If I just do it this way, it'll be a little bit better. If I do it this way, a little bit better. So there's this sort of like intrinsic desire to make these perfect APIs. And that's an iterative process. So at the in early days of Rust, I think like now, there's just a lot of churn, even in relatively low level kind of what would be fundamental kind of libraries and APIs. And I think it's getting a little bit better, but this is for sure, I think, a cause for a lot of time investment. Even if your code hasn't changed, just to keep it sort of up to date takes some effort at the moment. There's slow compile times. It's very commonly known and appreciated or not appreciated by Rust. That's clearly also getting better. There's a relatively small ecosystem or ecosystems for all kinds of things that people want to do. This is definitely getting better. There's a lot of really exciting code coming up, but it's still the case that for many different tasks, there's not a plug and play solution. So these are all getting better, and maybe tonight we can discuss our own little corners of the world and how we can work on this. So tonight we've got we've got 3 speakers. So Danielle McKenna is going to talk about a potential future for observability in computer vision pipelines. Jordan Worley is going to give a brief introduction to photogrammetry, and Matthew Piesenberg is going to talk about photometric stereo on the web thanks to Rust and WASM. And then, so I think with those 3 speakers, hopefully we're going to have then some time for open discussion afterwards. And I think that's my last slide. Let me check. Oh, no. So maybe during these talks, maybe think about these questions, because then at the end we'll have some time for this open discussion. So simple question would be, when should we meet next? And do you have any suggestions about the format? You know, this format, what we're doing tonight, is kind of what we discussed a little bit on Discord, but it can be easily changed. Then maybe more weighty topic. What kind of fundamental libraries, do we want, and what needs to be built or what needs to be improved upon? So I think this would be a potentially fruitful topic for discussion. Another interesting topic for discussion would be, what are you working on? There's a lot of interesting things I know going on out there, and I'd love to just hear about those. And from my side also, what kind of file formats do you use? So I think that's another area besides APIs that we could collaborate on. How do you store video? How do you store camera calibrations? All those kind of things. So those are my maybe suggested topics for discussion, but I don't really have any more agenda than that. And so those are my opening remarks. So let me go ahead and I've been recording myself here. I'll stop that.